Greetings. In this video, I'm going to explain how to evaluate an integral like this one, where you are given two limits, the lower limit and the upper limit. To evaluate such kind of an integral, what you're supposed to do is understand how this rule of integration works. So the rule states that if you have the integral of, if you want to find the integral of ax to the power n, where a is the coefficient, x is the variable, and n is the power, what you're supposed to do is get this expression as it is, ax to the power n, add 1 to the power, then divide everything with your new power, which is here, you can see it's n plus 1. So you divide this whole expression with the n plus 1. If you understand how this rule works, let's go ahead and use it to evaluate this integral. So what we are going to do first is we are going to integrate this expression which is in the what? Brackets. To evaluate the expression which is in the brackets, we are going to first split the whole expression into simpler parts. So since it's the integral of this whole expression, I'll do the integral of 6x to the power 5 dx. There's a minus there, so I say minus the integral of x to the power 4 dx. Then the next one is a plus there, so I say plus the integral of 3x to the power 2. Then I have a minus there, the integral of 1 dx there. Is that okay? So once I split this whole expression into separate parts, I can work each one of these individual integrals using this rule here. Is that all right? So let's start with the first part here. The integral of 6x to the power 5 dx. So if we work out this individual here, I'll say the integral of 6x to the power 5 dx is equal to, I'll get the 6x to the power 5 as it is, so I'll say 6x to the power 5, then I'll add 1 to the power, then divide this whole thing with the new power, which is 5 plus 1. So what does this give us? We have 6x to the power, 5 plus 1 is 6, then I'll divide this whole thing by what? By 6. So you can clearly see there that this 6 will divide with that 6, leaving us with x to the power 6. This means that if we integrate 6x to the power 5 with respect to x, which is the x, then what we expect as our answer here is this, simply x to the power 6. So the first part is done. I go to the next part now. So we have a minus there. I will erase off this so that I can write my next part there. So the next part is the integral of x to the power 4 dx. So what I'll do is the same as we did with the first part. So I'll say x to the power 4 plus 1. I add 1 to the power. Then I divide this whole thing with the new power, which is 4 plus 1. So you see, this will simplify to x to the power, what is 4 plus 1? It's a 5 over, and 4 plus 1 is what? 5. Is there anything we can do to simplify this expression here? No. So just going to pick it as it is. So the integral of x to the power 4 dx, which is this part here, you see that the integral of that part there is simply x to the power 5 over 5. So I'll go ahead and write this as x to the power 5 over 5. I go ahead and work out the next part. Our next part here is the integral of 3x squared dx. The integral of 3x squared dx. What does this give us? So if you have this 3x squared dx, you want to integrate it, you write it the way it is, 3x squared. Then what do you do? Add 1 to the power. Then divide this whole thing with a new power, which is 2 plus 1. So what do we get there? You have 3x to the power. 2 plus 1 is what? 3. Over the new denominator is 2 plus 1, which is also what? 3. So clearly here you see that the 3 and the 3 will cancel, meaning that you remain with x to the power 3. Is that okay? So if we integrate this part here separately, like what we have done here, you see that it is going to give us a positive x to the power 3. Let's go ahead and integrate the last part of the expression. So the last part of the expression is the integral of 1. So the rule is the integral of a constant number with respect to x is simply going to be x. The integral of a constant number, if you have a constant number which does not have x on it, what you're going to get there is simply x. Let me explain here how this x comes about. So we know if you have a 1 like this one, it simply means that the power or the value of x that this one has is x to the power 0. Why? Because x to the power 0 is 1 according to indices. X to the power 0, we know that in indices x to the power 0 equals what? 1. So if x to the power 0 equals 1, then our 1 here is the same as saying 1 times x to the power 0, which is 1 times 1, which gives us what? 1. That's why we just see this one here. So even if we were the 2 here, it will be 2 to the power 2 times x to the power 0, which is just the same as 2 times 1. I really hope you understand what I'm trying to explain here. So if we apply this rule here on 1x to the power 0, we are going to say plus 1 here, then divide this whole thing with 0 plus 1. So you see there, 0 plus 1 is what? X to the power 1 over 1, which just gives us what? X. So to save you from this trouble here that is happening here, it is just important for us to understand that the integral of a constant number is x. So if we had a 2 here, for example, if we find what is the integral of 2 with respect to x, our answer will be 2x. If we want the integral of 5 here with respect to x, what we're going to have is what? 5x. Similarly, the integral of 1 dx is just 1 times x, which is just the same as what? X. I really hope that makes sense. So here where there's the integral of 1 dx, we just replace that with x. Once we are done with that, I'll do that. Then I'll put my limits now. So here we have -1. On top there we have what? 2. So to work our way through to the final answer where we are going to evaluate the final value, we're going to replace this value in this new expression that we got by integrating. So the integral of 2 is equal to, I'll replace 2 in this expression. So this is the upper limit. I'll start with the upper limit. So I'll say 2 to the power 6 minus 2 to the power 5 over 5 plus 2 to the power 3 minus 2 there. So here we're supposed to have a minus here. Here we're supposed to have a minus because we have a minus on top here. So this is supposed to be a minus. So if we simplify this, we're going to have 64 minus 32 over 5 plus 8 minus 2. Simplifying this further, we're going to have, if we punch this in our calculator here to simplify it, we're going to find that our answer is 318 over 5. So using a calculator, you can quickly work out our solution to be 318 over 5. So I'll go ahead and find the other part where we replace with -1. So if we replace in this expression with -1, we're going to have -1 to the power 6 minus -1 to the power 5 over 5. Then we have plus -1 to the power 3. Then we have minus -1. So if you simplify this using your calculator, it is going to give you a 6 over 5. Simplifying this with your calculator gives you a 6 over 5. So once we have these two here, the I1, I2, the integral of 2, meaning that what we got when we replaced in this integral here with 2, and the integral of -1, meaning what we got when we replace here with a -1, then we can go ahead and find our final integral, which is the integral is equal to the integral of where we replace with 2 minus the integral of where we replaced with -1. So what will this give us? So we're going to get 318 over 5 minus 6 over 5. If you work this out, you're going to see that it is going to produce, since the denominators are the same, the numbers down there are the same, I'll just pick the 5 there and then work out the top. So it's 318 minus 6. What does this produce here? It is going to give us 312 over 5. So if we divide this here, we're going to have 5 into 31 is 6, remainder 1. I put 1 on the 12, on the 2, so it becomes a 12. 5 into 12 is 2, remainder 2. So I'll write my remainder 2 here. So 5 into 2, it can't, I put a point there at a 0. 5 into 20 is 4. So we get 62.4, or we can just say this 62 for remainder 2 over 5. So then we say units squared there. So this is our answer, or we can pick that as our answer. Yeah, so this is how you roughly are supposed to work your way through if you're going to evaluate an integral. So this is how you work your way through if you're going to evaluate an integral. The first thing you're going to do is you're going to use this rule here to evaluate what the integral you're given. Integrate each part separately, then work it out and find the integral. Once you have your integral there, substitute your limits. The first one, work it out and see what it gives you, the top one, which is called the upper limit. Then also substitute the lower limit in this expression that you are given. Then once you have your two limits, this is the upper and this is the lower, then you can subtract them. The upper minus the lower, and see what it gives you. So basically, this is the idea behind the evaluating integrals. I hope you find this video to be helpful. Thank you so much for watching. Don't forget to like this video and subscribe to the channel. It will be very helpful and kind of you. Thank you so much. See you in the next video. Bye.